myself Vikas Singh. So in this class, I hope by now you all have gone through the basics of bargaining game. Did you remember one period game, that's the ultimatum game? Did anyone of you remember? Because whatever we are going to do today is solve some mathematical calculation for a multi-period game where it is mainly based on somewhat related to ultimatum game, that is one period game. So do you all remember one period game? What actually happens there? Okay, for you, let me remind. For example, some players are coming together, and due to which they are gaining some surplus. In this case, definitely they have to ensure how to divide this. They have to make some mechanism, make some model so that they can divide the surplus among them. In that case, let us suppose there are two players, player one and player two. So if player one is making a proposal, somehow he is the one who is starting the game. In that case, let us suppose we can divide this surplus in the form of x minus 1 minus. That is the proportion I am saying. Here x means proposal. So let us suppose the player 2 has two options. Either he can reject, or either he can accept. So in case if you reject, both will get 0. Okay? But in case the player to accept, then they will have an option to get a payoff of x1. I hope by now you will remember what we have studied till now. Okay? Is there any problem? So in case, but anyway, we are not going to discuss all this. But for your, uh, so that you can understand what we will do today, I'm again repeating. In case if there is discounting factor, you remember discounting factor? Player one, for example, player two, for example, if two of the players are bargaining for a multi-period game, in that case, definitely, if they will not be able to form a contract in period one, there will be loss in value if they're going for a period one to period two to period three by a discounting factor lambda. Do you remember that? Because time is very costly, so here we are assuming that if you are wasting your time, there will be loss in your payoff. So that will be shown by lambda. So again, I'm repeating: if player one is making a proposal with a value of x, comma 1 minus x. Here x is the proportion. So now player two has two options: reject or accept. So now, if for example I am writing here reject, here is accept, whatever Buddha says. Again, he will make some proposal, but here in this case they are getting a portion of x comma 1 minus x, but in this case their discounting factor is applicable. They are not going to get a proportion of x comma 1 minus x. That is, b1 will be getting a payoff of x and b2 is getting a payoff of 1 minus x. But in case of discounting factor, they will get portion of. Do you remember this? In case of discounting, when the value of the surplus will be decreased when they are moving from period 1 to period 2, so their payoff will be written as del x 1 minus x into del x. Do you remember this? The del is between 0 to 1. Did you all remember? Okay, in case if you remember, then we are going for a finite period game, or I would say a multi-period game, both are same. So first of all, I will draw a graph. Suppose okay. So this is what we are talking about. So anyway, you remember this is okay. So player 1 is making an offer. Then now the player 2 has two options: accept and reject. In case he is accepting in period 1, he will be getting a payoff of 1 minus x, while player 1 will be getting of x. While he rejects, again he make an offer, but in that case, offer will be del x and del 1 minus x. So now we'll look on, for example, let us suppose we are dealing with a finite time period game. For example, you can ask there could be a infinite period of game, but in that case, it will definitely we will look on that as well. But for now, we are looking on finite many rounds of bargaining. That is finite finite many periods, many rounds of bargaining. So here what we are assuming that t is less than infinite. So that means it's a long game. It's a long period game. That means there are many multiple bargaining between two player will occur, but that period is less than infinite. That means it may be 100, it may be 10, but it's not infinite. For example, then okay, can somebody tell me why we are not using Nash equilibrium, rather we are using subgame perfect equilibrium in this game when we are talking about bargaining? Okay, so throughout game theory, we always try to calculate Nash equilibrium. So do you know what is Nash equilibrium? Anyway, like a point where both the players will intersect together and have a payoff whether neither of the player will that can deviate and get a higher payoff. So now I want to ask why this is not working in bargaining game or free game. Can somebody, anyone? Okay. So basically, in Nash equilibrium, you all know that players try to adopt a strategy by looking on what others will do, and they will try to adopt a strategy as they are trying to adopt a strategy where they will be able to get a higher payoff. At the same time, they always try to select a strategy that will not also motivate others to deviate from their strategy to get a higher payoff. But in this case, it will not work because in that case if you will apply the same concept in this tree, then it will be a kind of game where the both are selecting a mutual best strategy for others rather than selecting a best strategy for themselves. So that's why in this tree game it won't be work. Rather here we are assuming since the players are rational, we will look on sequential rationing because it's a multiplayer game, finite horizon game. So we will be looking on sequential game. So let us suppose we are supposing, for example, let us suppose okay. So this is graph. Okay. So first of all, let us suppose in period one, the player one is offering a payoff of x, comma 1 minus x. That means here player two is getting a payoff of 1 minus x. Now, if the player 2 will reject this payoff, if the player 2 will reject this payoff, and in that case, player 1, which initially has a advantage of knowing and making an offer, will be in disadvantage case because now the player 2 will be in a position to propose the proportion of surplus that can be divided into two players. Now here there are again two cases: accept and reject. So if we are supposing that it's a two-period game, then in that case, if again the player one will reject, it will be a loss to both of them. So anyway, if it is a two-period game, the player two or one both have to accept. So what I'm saying, if it's a two-player game, then if two, that is in second period, where the player two will make an proposal, in that case player 1 has to accept because if he reject, in that case both of them are going to get 0. So what I'm saying, now the player 1 has an advantage since he is moving first. It's a first move advantage. He can make a proposal, he can divide the surplus in such a manner that the player 2 should not reject it in stage 1. Did you get my point? If player 1 is moving first, that is he has a first move advantage, then in that case he can make a proposal in such a manner that player 2 should not reject it. Okay, now what he can do? Can you tell me what he can do in that case? Okay, let me. Okay, so now let us suppose initially the value of surplus is lambda. So sorry, 1. Okay, I'm just supposing it for a, so to make it the problem simple. And now what I'm saying, if it moves from period 1 to period 2, then its value will be with lambda. Did I get my point? And because if you are moving from period 1 to period 2, there will be a loss of some value. Okay, so that initially it was value, let us suppose 100, initially total payoff that can be distributed to place 1, but now since they are moving from period 1 to period 2, that this is the only amount of money that can be distributed, a surplus that can be distributed between the two players. Okay, so now what will be the payoff of two player? In that case, V1 will get relative that. So somehow this will look like their payoff. Okay. So now can you tell me what should be the distribution of payoff between the two players in period 1 so that the player 2 should not reject the proposal that is being made by player 1 in period 1. Can you make anyone any guess? Are you able to understand what I'm saying? Or no? Are you able to understand what I'm saying? No? Should I repeat? I'm asking in period 1 how the player 1 should make an offer so that player 2 should not reject the offer in period 1 itself, because we don't want to provide period 2 an option to make an offer, because if you are moving from period 1 to period 2, there will be a loss of surplus. So what we are saying, in period 1 itself, the player 1 should make an offer in such a way that the game should not shift from period 1 to period 2. So did you get the point? So here, what should be the distribution of payoff between the two players in period 1 itself, that there should be no case of player 2 rejecting it. Can you make a guess or maybe calculate?
So 1 minus x should be greater than the payoff of player 2 in period
1 minus x should be
greater than the payoff of player 2 in period 2.
1 minus x should be, yeah, right. But what should be the calculation?
Greater than or equals to
Right, you're right. Absolutely right. Okay. So, okay, this is what they are saying, they are correct. Because if the payoff should be such that if this payoff that a player 2 is getting in period 1 is greater than payoff that he will be getting here, in that case, the player 2 will not reject this offer in the period 1 itself. Okay, now what will be the case if there will be no discounting? What I'm saying right now, let us suppose it will become 1. So what I'm saying, in period 1, if the value is 1, let us suppose the total surplus is 1, and because they are moving from period 1 to period 2, there will be decrease in total surplus that can be divided between the two players. But now what I'm making a statement that there will be no decrease, there will be no change in surplus. It doesn't matter how many rounds you are interacting or you are trying to, distribute the surplus. What I'm saying, between change of period, there will be no change in the value of surplus. In that case, what will be the outcome? Did you get my point? So here, in simple case, there are loss of value if you are moving from period 1 to period 2. But now I am saying there will be no loss of value if you are moving from one period to second period. In that case, what should be the outcome? Can anyone? Okay. So as we are seeing in game 1, since player 1 is moving first, and there will be a decrease in value of surplus when they are moving from period 1 to period 2, while there will be a decrease in the value of surplus from when we are moving from period 1 to period 2. It's better to accept or to make an offer in such a way that payoff that the player 2 can get in period 1 should be greater than payoff what the player 2 can get when he make his own proposal in period 2. Are you able to understand? Or I'm making some mistake? I should speak slow or something. So now what I'm saying, if there is no decrease of value, when we are moving from period 1 to period 2, period 2 to period 3, so in that case, what will happen? Since it's a 2-period game, and the game will end at period 2, that means whatever decision, the game that is in game second period, whatever decision will be taken will be a final decision. So now what will happen? The player 2 will make a proposal in such a manner that he should get everything because it's the last period of the game. So whatever decision he will make, it will be a final decision. It's a take it or leave it a game because we are at the end of the game. It's a last period game. Maybe it's a 100-period game. It doesn't matter. If it's the last period of the game, and if del is equal to 1, that means there is no loss of player. Then whoever know that he will play in the end of the game, he will wait till there and he will make their final payoff in such a manner that he can get everything while other will get maybe 0. Do you have any confusion? But in case if there is a discounting, you have to take like we have to again calculate that we will do right now. Don't worry. Do you understand what I'm saying? Did any one of you understand? Is there any confusion in that? Either you're saying yes, no. Are you able to understand what I'm saying, or I'm making some confusion rather than making it clear? Okay. So now we have seen the two very important cases. The case one, when we are discounting the value, that will do some mathematical calculation of what should be the strategy of each and every player. When we know that they will be discounting each and every player. While the second case is very simple. Whoever will play last, because del is equal to 1, that means there is no discounting. In that case, the player will try to wait for the last period. Again, it's depending on that game, we will look on how all this happen. But for simplicity, you can say if del is equal to 1 and it's a 100-period game, we are supposing, then at the end, the player will always try, the player who know that I will be playing at the end will wait till there, and in that last period, he will make a proposal in such a manner that he will get the maximum payoff because he or she know that it's the last period of the game, and anyway the other player has to accept this offer. So now what I'm saying, let us suppose it's a T-period game. In that case, payoff of 1 will be delta T minus 1. Why I'm saying this? If I will write delta here, delta T minus 1, it's a 2-period game, so it will convert to this. Did you understand why I'm writing delta T minus 1? So as I've told you, if it's the last period of the game, then the first player, if I'm supposing the game will end in such a manner that the first player will be the first mover, as well as he has the advantage of offering in the last period as well. So in that case, he will take everything for himself, while he will offer 0 for others. Do you agree with that? Because it's a discounting game. When you are moving from period 1 to period 2, they will be discounting the value. So now you can see because of that, the value will be look like that. The payoff of player 1 will be del T minus 1 upon and V2 will be 0. Now you tell me, if you are moving from T to period T minus 1, what should be the case? Okay, let me tell you. So in that case, you can see if this is the T8 period game, where it's the end of the game, that means this would be the last period of the game. Anyway, we have written finite many period round of bargaining. So I'm supposing the game will end at T period. So payoff will look like that because in here we are supposing also that the player 1 is the first mover and last mover as well. So what I'm saying, if he is going to make a proposal at the end, the player 1 is going to make a proposal at the end, he know that the player 2 doesn't have any other option, so he'll take everything. While he will give 0 to others. Now what I'm saying, to move backward in action. So now what we are doing, we are solving it from back to the front so that we try to find out what should be the proposal of player 1 in the first period itself, that player 2 should not reject that proposal in first period, so they don't have to go till period T. Do you understand why we are calculating and why we are going from back, why we are using backward induction? We'll go from T8 period to the first period and we will try to find out this. What should be the proposal here so that the game should not go to T period? You know what I'm saying? Okay, so we are moving. So that's why we are starting from backward induction at T period. So T minus 1 period. How it should look? It should be, okay, this is the T8 period. So what I'm saying, the value that, so now here, okay, here player 1 is proposing. Anyway, it's a last period of the game, but player 1 is proposing, making a proposal, is making a, okay. So here in T8 period, player 1 is making a proposal. So now you tell me in T minus 1 player who will make the proposal. That is even period game. Okay. So now you tell me what should be the strategy of player 2 so that the player 1 should not reach the T8 game. Anyway, you are looking from backward to first. So we are looking at a backward induction game. So T8 period, we know what should be the payoff, what B1 will take for himself. So now if we will move from, we know this value. So now we are looking at this. So what should be the, because here second player is making an offer, what should be the offer made by second player so that the game should not reach here? What should be the payoff? You tell me. So here B1 should be greater than T minus 1. Do you agree? That means del T minus 2 into X should be greater than. Where is that? Do you understand what I am saying? Here del T minus 2 into X, the proportion that what player 1 will get in this period when player 2 is making a proposal should be greater than what he can get from himself at period T. Are you able to see? Last minute. Are you able to see T minus 1? So what I'm saying? At point T, when player 1 is making a proposal, he can get this one. So when we are looking at point T minus period T minus 1, where player 2 is making a proposal, what we are saying, in that case, if the player 2 will make a proposal in such a manner that this payoff that the player 1 can get in period T minus 1 should be greater than what he can get from himself by making a proposal in period T. Are you able to understand, or I'm making some confusion? Is it clear for you? So now, from looking at all this equation, you can say X should be equal to lambda. Okay, or greater than lambda, whatever. In that case, the payoff will be, at least player 1 will be able to get payoff what he is getting by making his own proposal at period T. Okay, do you agree with that? And if the player 2 will make a proposal of lambda, in that case B2 will become okay. Is there any problem with that? क्या बच्चा? Red shirt, T-shirt. देख ही नहीं रही हो तो क्या पड़ेगा? Okay. So, do you understand? Because in case if you not understanding this one, you won't be understand the other period as well. Okay. So I'm again repeating, in period T, player 1 is able to make a proposal in such a manner that he is getting a payoff with the, and here since it's the last period of the game, he will give 0 to others. So now if you are moving from this period to this period, so here the player 2 is making a proposal. So in that, why player 2 is making a proposal? Because anyway, it's a 2-player game, so if one is making, then other will making, then again one is making, second is making. Do you understand why player 2 is making proposal here? Okay. So if player 2 is making a proposal, he should propose the division of surplus in such a manner that whatever payoff the player 1 is getting in the last period, that is this period, should be greater than the payoff that he can get in t minus 1. That's why I have written del t minus 2 into x should be greater than equal to del t minus 1. So after calculating, we'll get, as we know, in that case, x should be equal to lambda, because then only his payoff should be greater than equal to what he can get as t period. So if x equal to lambda, the payoff that 2 will get equal to lambda t minus 2 into 1 minus lambda. Are you able to understand why this happened? Because why t minus 2 written? Are you able to understand? Because we are talking a period t minus 2, and if total surplus is 1, the division will always be x comma 1 minus x. Okay, so if we are giving a proportion of x to player 1, definitely the rest of the player is the proportion of surplus to other will be 1 minus x, and if x equal to del, because of that, the payoff that player 2 will get in this period is del t minus 2 1 minus lambda. I hope by now you understand why we have written all this. So now you tell me, if we'll move from t minus 3 to period t minus 2, now you tell me which among the two players will move first. Right. Because in the last t minus 1 player 2 has moved, so in this case, player 1 will move. Now you tell me what should the strategy of player 1, so that the game should not move to the next period, because we are looking at a backward induction. So now what I am asking, what should the division of surplus by player 1, that the game should not move in the next period. That means what I am saying, what should the division of player by player 1 in such a manner that the player 2 should not reject it. I hope by now it will be clear what we are doing. So can you make a calculation? Like, can you do what should be the case where the player 2 should not reject whatever being given by player 1? If you are able to understand by now, definitely I am sure that you will be able to calculate. Here, the payoff of player 2 should be such that it should not reject the division of surplus by player 1. So in that case, how the player 1 should make a division? Or what should be the case? Forget about what division he will make. What should be the payoff of player 2? Can you write? What should be the payoff of player 2, or what should be the condition here, so that the player 2 should not reject the proposal of division between the two? Can you write the condition, single line equation, where player 2 should not reject the proposal made by the player 1 for the division of surplus? Why? Delta t minus 2.
delta का 3 minus 3
ठीक है,
into 1 minus 6
ठीक,
should be greater than 3.
राइट. और किसी को, anyone else? Same. So delta 3 minus 3 should be equal to can you solve? From here we can get the value of x. How do you solve it? Are you able to solve? Okay. So can somebody tell me what the value of x?
Delta square minus delta plus 1.
Delta square minus.
Delta plus 1.
Okay, correct. I think this is what you can get. Bacha, this is what you are saying.
Yeah.
Okay. So now, if you have this value, you can easily get the payoff that the player 2 will get here, right? So can you calculate what should be the payoff of player 2 in this case? Anyway, it's very easy now. So now, since we know the value of x, what should the payoff of v1 and v2, that is player 1 and player 2, will be del t minus 3 into x, and v2, the payoff of player 2 will be del t minus 3 into 1 minus x. So I hope you know why we are writing 1 minus x and t minus 3. Or should I repeat? So you can calculate. Okay, anyway, there is no use of calculating. But again, so are you writing v1, v2 for each period? Because that will be helpful when we'll analyze the overall what pattern they are following. Are you writing on this? No? Okay. So if you're writing in that case, we can move to period t minus 3 in case if you're moving to period t minus 3 where the player 2 will move. So now you tell me, since here player 2 is moving, what should be the strategy of player 2? What should be the strategy of player 2 in period t minus 3 when he's making proposal? Can somebody?
Player 1 shouldn't reject.
Okay. What should be the payoff in that case? In that case, the payoff should be such that should be greater than equal to what payoff that he can get here. Okay. So what's the value of? So what did you get? Are you getting something similar to this? So now from here you can calculate x. Can somebody tell me what should be the value of x in this case? Okay. So now you can easily get the value of v1. That is now you can calculate the value of v1 and v2. Okay. Are you able to understand what I'm saying and why we are moving from why we are using backward induction? So that we can calculate what should the proposal that is being made by player 1 in period 1 so that the player 2 should not reject this proposal and the game should end at the period 1 itself. Okay. Can anyone repeat what I have said? Anyone? What I'm saying? Why we are using backward induction? Because we are trying to find out from moving from backward to first period so that what should be the proposal of player 1 in such a manner that the player 2 should not reject this proposal and the game should complete at the period 1 rather than moving to period 2, period 3, period 4. So the player one, we are trying to find out what should the proposal of player one in the period one itself, so that there is no need to move from period one to period two and many other periods. So we are trying to find out the x, the proposal ratio, so that the game should not move from period one to period two, and the game should end here. We are trying to find out what should be the proposal ratio of division in such a manner that the game should not, because it's a waste of resources. Now I hope you understand. Can someone repeat what I have said just now? What we are doing? Why we are using backward touch? Okay, in game, then period. Okay, by now you would understand. You would have understand that we are somewhat following a pattern. Okay, so if you look very closely, we are following a pattern here. That is, for an odd period game. Odd period game is when the player one is moving. Even period game means when a player two is moving. And with just a name, don't have to remember. You just remember that after one, who is starting, who is ending, and if one player is starting, that definitely second player will move after that. So we are naming it an odd period game, odd player or whatever, what odd player game. That case, we can see a pattern here. That is, and similarly for an even period game, we are are you all also getting the same answer? If you solve this iteration again and again, we'll get a pattern which is similar to this. For an even period game, that means when player 2 is making a proposal, in that case, x always follow a pattern which is similar to this. While for an odd period game, you solve the same equation, then x always follow a pattern which is similar to this. Okay. So now what I'm saying, if I'm taking this one, let's suppose I'm taking this one, x will look like now. Can you find out what should be x? I've given you. Okay, let me again make it further solid. Okay. Now can you find out what shows the value of x? First of all, you tell me what pattern you are following. And just by looking at the equation, huh? Who said GP? Hmm. Right. You're following this pattern. A is AR square. So what is the sum of GP? Huh? A of into 1 minus r to the power of 1 minus r. सही. Infinite तक होगा तो in case of that A upon 1 minus r. ठीक है. Can you solve this? Please try.
నేను నీ ఫేస్ చూస్తా, నీ ఫేస్ చూపిస్తా వీడియోలో పెట్టు. బాగా స్మైల్. బార్గెనింగ్ లాస్ట్ టాపిక్ పుట్టినవాడు అర్థం. స్టాప్ వీడియో.
You're saying right, but you're doing it wrong. You're saying it wrong. So let me give you a link. First of all, take this one. Just solve it one by one. Okay. So I'm supposing it as SP. Just you can name it anything. It doesn't matter. Okay. So for example, okay, I'm just taking. Let us suppose one is there, but I'm okay. I can also write this the part one as. Just I'm taking part one. It will be there, don't worry. I'm just telling you how to solve it. You can write the above part as this one. Okay. Then tell me what should we do. I told you like 90% of things. We can also write the part one as this.
That is also 1 plus delta square is
Okay, so you're saying minus 3 will be there.
Yeah.
it is same as x1.
Okay, what else saying right now?
x1 equals to 1 plus delta square into x1.
It's equal to 1 plus delta square into. Okay, now what I'm saying? What are you okay? What are you saying there?
That is a GP6.
Okay. So now what I'm saying, how to solve this? I'm supposing SP equal to. Now can you solve this?
So we know the formula. A upon 1 minus r.
It's for infinite game. It's not an infinite game.
A into r power A into r power
A to 1 minus r plus 1 minus r. Okay, you can solve. You try to solve it.
T minus 2 by 2.
I've given you.
1 plus delta square. Even times exponent ఒకటే. డెల్టా కాంబినేషన్ మ్యాచ్ చూసాను.
r power n.
ప్లస్ అది ఇది సేమ్ క్యాల్కులేట్ చేస్తాను. ఏం క్యాల్కులేట్ చేస్తాను? बनाना खाके